everyone, welcome to the Ionic bonding revision sheet. Let's start with the central part here. So on the periodic table to the right, identify each group using numbers. So we have previously looked at that on the last revision sheet, but it doesn't harm looking at it again. So the groups are 1, 2, 3, 4, 5, 6, 7 and 0 or 8 on the end. Brilliant, that one's done. Next one, identify the elements that form cations. So cations are over on this side. They are positive ions. So I'm going to highlight that. We'll talk more about positive ions shortly. That one's done. Identify the elements that form anions. These are negative ions. They're found on that side. So anion. There we go. Brilliant. Let's look at our definitions then to help us with that. So we go back on here. What is an ion? An ion is a charged atom. It can be positive or negative. What causes an ion to be formed? So it will lose or gain an electron. Okay, what is the charge of a cation? So we've already said that, that is positive. What is the charge of an anion? That is negative. So it's just something that we need to learn. So I'm going to highlight that. Cation is positive, anion is negative. Let's look at this one down here now. Identify this element using the periodic table to help you. Okay, so we did that on our last revision sheet. So let's have a look. So there are 2 shells. So it should be in period 2. And in the outer shell, there are 2 electrons. So 2 electrons in outer shell. That means it must be in group 2. So it's in group 2, period 2. Let's get my periodic table out. So here we go. We're in group 2, which is this column here. Period 2. So remember there's 1 across the top where hydrogen is 1, 2. So it is beryllium, Be. So Be is beryllium. Because it has 2 shells, it's in period 2, 2 electrons in the outer shell, so it's in group 2. Okay, let's just scoot over to this side because that will help us with the rest of the sheet. So we've got our group numbers 1, 2, 6 and 7. That's what we need to know about. If you look at the specification points, it talks to you about that. So how many electrons in the outer shell? Well, we know the group number tells you how many are in the outer shell, so that's pretty easy to fill in. We just copy the numbers. So 1 is 1, group 2 is 2, group 6 is 6, and group 7 is 7. So number of electrons that can be lost or gained. So in this one, it's for the group 1 and 2, forming cations, positive ions. It's simple, it's just the same number. So 1, and that'll be lost. And that could be 2 lost, 2 in the outer shell. Let's just focus on this one for now. So the charge of the ion, if it's lost an electron, it becomes positive. This is lost 1, so it's 1 positive. Okay, and that one's lost 2, so it's 2 positive. Okay, so is that anion or cation? Well, it's positive, so it's cation. Both these are cations because they're positive. I remember because the T looks like a plus. Let's look at these ones a bit more tricky. Group 6 and 7. So we're looking at filling the outer shell. So if we remember from our previous learning, we can have up to 8 electrons in the outer shell. So we're trying to make this 8. So 6 plus 2 is 8, so that has to be 2 gained. And then for the 7 to make 8, you have 1 gained. Okay, if you gain 2 electrons, each one is negative. So I'm going to gain 2, so it's minus 2. This is quite hard getting our head around because it's simply opposite to what you think. If you gain 2, you might think it'd be positive, but you have to remember electrons are negative. And here that's 1 gained minus 1. So this is an anion. That one's an anion as well. Okay, negative ions. Okay, let's have a look at this over here. So it says draw the electronic configuration of the following ions. So sodium, Na. So I'm going to find sodium first of all. So sodium is in group 1. So I'm just going to note that down. Sodium is in group 1. So it will, if I look on here, group 1, it will lose 1 electron. So it loses 1 electron. I'm going to write E- for electron. If I have now got to get the periodic table back, finding sodium again, the atomic number is 11. That means there are 11 electrons in total. So 11 electrons, but I have to remember it lost 1. So if it's lost 1 now, he's got 10 electrons. Okay. So let's start drawing this. I'm going to write Na in the middle here. I'm going to put some shells around the outside. So it can put 2 in the first shell, 1, 2. And then there'll be 8 in the next shell because 2 plus 8 is 10. So 1, 2, 3, 4, 5, 6, 7, 8. So that is adding up to 10. It does say 11 electrons, but remember it's a positive ion. It's a cation, so it's lost an electron. So it's lost the one in the outer shell. We don't have to draw the outer shell. To show that it's an ion, and we know that, we're going to do these little brackets around here, and we're going to put a negative at the top just to show that it has lost an electron. Not an electron, sorry, not a negative, it's a positive. See, even I get mixed up on that. The reason I worked out I was wrong. So I look on here, oh look, it's a +1. In group 1 it must be a +1. And if I look again on here, Na+, it must be a plus on there. Okay, let's try the next one, chlorine. So I'm going to find chlorine in the periodic table. So chlorine is over here. It is in period 7. Okay, so, sorry, group 7. So it's group 7. If I then look over here, group 7, it gains 1 electron. So gains 1 electron. So I then look at how many electrons it's got in total on the periodic table. It has got 17. So 17 electrons. And it has gained 1, so that makes it 18 electrons. So I'm going to draw my configuration. So we've got Cl in the middle, I've got some circles around the outside. So I'm going to put 2 in the first orbital or shell, 8 in the second, 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8 is 10. I need to make 18, so it's another 8. 1, 2, 3, 4, 5, 6, 7. And with the 8th one, I'm going to show that it's not come from chlorine. I'm going to draw a dot there. That signifies that this electron I know has come from somewhere else. It might have got it from sodium, for example. It's lost an electron that's given it there. So I'm going to draw my brackets around the outside. And then my charge is going to be negative, 1 negative. So there you go. I've got the electronic configuration for the following ions, sodium and chlorine. Okay, I could write it out as well as 2.8 and 2.8.8. But I'm just going to draw it in this instance. Okay, next one. Draw a diagram to show the structure of an ionic compound. So these ones I'm going to show with circles. Now it's not necessarily the best way to show it because it implies that these atoms are all the same size, which they're not. They're different sizes. You can just see from the electronic configuration they're not the same sizes. We're just going to imply that they are. Each one will have a charge, and the charges go in the opposite manner. So a positive will be surrounded by negatives, and negatives surrounded by positives around here. So this is called an ionic lattice, and it has strong electrostatic attraction, also known as ionic bonds. So the electrostatic attraction is the positive and the negative being attracted to each other. This means that it takes quite a high temperature to melt this compound, because you need to overcome these electrostatic attractions, so these ionic bonds. So let's go on to the last section. Write the formula of these ionic compounds. Okay, so we have got some formulae of sulfate, hydroxide, nitrate and carbonate over here with our charges. And what you have to do when you're making an ionic compound, you have to equal the charges, because overall they'll have no charge. Okay, so start off with sodium. So I'm going to look at sodium on my periodic table. Here's sodium. So it can lose 1 electron because it's on group 1. So I have a charge of +1. So Na plus. And then hydroxide, I'm going to look over here, is OH minus. So then I'm just checking, are the numbers of pluses and minuses the same? Well, they are. There's 1 plus here and 1 minus there. So therefore, we're forming that formula there. So we can just remove the plus and minus because they're equal. Copper sulfate. So copper has a charge of 2 plus. Sulfate is SO4 2 minus. So there we go. Again, we're looking, are they the equal numbers? Yes, they are. 2 plus and 2 minus. So the formula is CuSO4. So just remove the pluses and the minus. Calcium carbonate. So calcium is 2 plus. Carbonate is CO3 2 minus. So again, we're looking at those. They balance each other out. So it should be CaCO3. Just make sure your numbers next to the elements here, they're small numbers at the bottom. There you go. Thank you very much.